Welcome to Part 5 of the Heathkit AP1800 preamplifier series. In Parts 1 through 4, I told you about the history of Heathkit's Pro Series components. We unboxed the 40-year-old new old stock kit, built the circuit boards, removed the corrosion, and painted the chassis parts and transformer. If you missed those episodes, you may want to go back and check them out. In this episode, we'll complete the build of the preamp. Let's begin. We took care of the corrosion on the large parts of our chassis, but some of the small parts are showing some signs of corrosion as well. Even our phono jacks have a yellowish-greenish tinge that I'd like to remove, and many of the screws are discolored and show signs of rust. So I've gathered the small parts that are showing signs of corrosion, and we're going to immerse them in our ultrasonic cleaner. And to the bath, I've added a couple of capfuls of Gemero. This stuff works well not only with jewelry, but small parts such as these. Let's give it a try. First, I'm going to turn on the ultrasonic cleaner. Place our items in the screen basket. And we'll let this sit for a while so the ultrasonic cleaner can do its job. Let's take our parts out of the ultrasonic bath and see how they look. Been in there for about half an hour or so. Just want to give everything a good rinse with water. Okay, pretty good. Don't look much different, but at least we know that we cut through it a little bit. Some of that yellow-greenish tinge does seem to have been improved a bit. This one phono jack has a bit of a dark spot there. I'm not sure if the plating has been removed or what's going on there. First I thought it was rust, but I don't think so. Let me take a closer look and I'll try to figure out what's going on there. I'm not really sure at this point. Let's look at the other parts. This was a part that had a fair amount of rust on it. Not too bad, but I think we're going to have to figure out a better way to polish this up a little bit. Maybe polish this with the Dremel polisher, or maybe try a little bit of the rust remover. Not too bad. These screws came out well. There was a fair amount of rust on these and looking pretty good. Okay, well, overall a good first step. Got rid of some of the corrosion. Let me touch up a couple of these pieces using some other methods. One thing to note, once you get these chassis parts wet, you've really got to make sure that they're completely dry. Not only to make sure that the water and the moisture doesn't lead to short circuits, but that it doesn't lead to further corrosion. I find that you can pat these dry with a towel, you can let them air dry, but still a lot of that moisture will sit in between the nooks and crannies, whether it's small parts like these or larger chassis parts, what have you. I want to show you what I do when I really need to ensure that parts are completely dry. What I use is this DataVac electronic duster. This thing comes in really handy, a real great substitute for those spray can dusters. This is electric powered and it works extremely well. Let me show you with the wet part. Nice and dry, and we don't have to worry about any remaining moisture. I was planning on soaking those small parts in evaporust, and I noticed on the instructions that it says it's safe to use this in ultrasonic cleaners. So I figured, hey, why not? Let's try this again to clean these small parts with our ultrasonic cleaner. But this time, instead of the Gemero, let's try it with evaporust and see if that doesn't work better for us. I've never used evaporust in an ultrasonic cleaner, so this will be fun to try. Okay, well, that's probably about 3/4 of this container, but I really don't want to dilute it, so let's go ahead and this way we'll give it a fair shake. It's been a couple of hours. Let's take our parts out of our evaporust ultrasonic bath and see how they look. Okay, all rinsed off. Let's take a closer look. Yeah, much better. This really seemed to do the trick, getting rid of all the rust on the back, and I don't see anything on the front as well. Let's look at the other ones. Still need to rinse these a little bit more, but look at that, no more rust. Okay, now let's look at some of the hardware. These pieces were quite rusty before, and you can see that they're actually somewhat shiny now. Big improvement. That one looks great. This washer was rather rusty, and you can see it's got a sort of a nice metallic shine to it again. And this piece as well looks great. Yeah, I don't see any problems with these parts. We seem to have gotten rid of all of that corrosion. Let's rinse these off a little bit more, and let's get back to building our kit. Here's a close-up of one of the phono jack assemblies after we've removed the corrosion. I just want to do a couple more things to this to prepare it before we put it in the chassis. As these jacks did have a small amount of corrosion, I think it's a good idea we try to protect them from that happening again. So I'm just going to spray these with a little bit of neutral control cleaner, and this is basically fancy WD-40. When we spray this on the assemblies, it'll leave a light coating that will help displace water in the future. And this will in no way negatively affect the electrical characteristics of these jacks, and even the light coating on this board will help to protect it. And while these are soaking, I'm going to use a Dremel tool to try to polish up these jacks a little bit. As you can see, I've attached a small wool polishing pad to the Dremel. Let's use this to polish up the jacks a little bit. So hopefully you can see the difference right away between this jack, which I've just shined up and polished, compared to the one next to it. Let's do the others. And now I'm just going to spray a little more neutral control cleaner over the jacks. Okay, I think that's good. Now let's use the electric duster to remove all that residual fluid from our jacks. Okay, looking fantastic. Let me do this to the other 3 jack assemblies, and then we can move on. If you saw the first video in this series, you'll recall that during the unboxing, we had unpacked this red tool, and I had indicated that I thought I had seen these in other Heathkits before and that it was called a nut starter. Well, indeed, that's what this is, and here's how it works. Sometimes with small nuts, it can be difficult to get them started. And you pick it up, and for example, I have to install this on this bolt here, and it can be tricky. So the way the nut starter works is you simply take the tool and you pick up your nut like that, and there you go. Makes it nice and easy. So that's our official Heathkit nut starter. So I was happily in the zone, blindly following Heathkit's instructions when I looked down and realized what I had just done. Take a look at the ceramic capacitor I just installed, and note that these are the AC accessory jacks, and the ceramic capacitor is going across the hot and neutral lines. Well, this is where this kit is really starting to show its age. Some of you may not know this, but with today's modern codes, this is a big no-no. If this capacitor were too short, it's going to connect the hot and neutral leads. And even though we have a fuse, that could be a dangerous situation. So nowadays we use safety capacitors when connecting to AC lines. In an across-the-line situation such as this, an X-rated safety capacitor would be warranted. And if a capacitor were connected to the hot or neutral to ground in a bypass situation, a Y capacitor would be used. And capacitors used this way are basically to cut down on noise from the AC line. So this capacitor needs to be removed and replaced with a safety capacitor. And fortunately, I have quite a few in stock. Here's a 0.01 safety capacitor, and this is rated for both X and Y applications, so it'll make a good substitute for this capacitor. Heathkit also provides 4 additional 0.01 ceramic capacitors, and these are used to bridge the switches on the AC circuit. These capacitors could certainly be used in that application, but if they were to fail short, if the unit was turned off, they would actually turn on part of the circuit. So I'm going to replace these 4 capacitors with safety capacitors as well. I'm going to remove this hazardous capacitor now, replace it with a safety cap, and continue to build our kit. At this point in our build, the power supply board is connected to our chassis, and it's connected to our transformer and the AC plug. Not all of the boards are installed right now, and nothing is connected to the output of the power supply. But before we proceed, Heathkit wants us to test the output voltages on the power supply to make sure everything is functioning correctly. And that's what we'll do now. But first, I want to switch the power switch to the on position on the preamplifier and slowly power this up with the variac and current limiter. Let's do that now and make sure we don't have any shorts. The power switch is just out of your view over here. Let me switch that on now. And the preamp is plugged into our current limiter. Let me switch that to the on position. And the variac is just out of your view back here. It's currently turned off and the voltage is set to 0. When I turn it on, you'll be able to monitor the voltage coming out of the variac on this meter. And as I do that, also watch the dim bulb current limiter. If it glows very brightly, that could indicate that we have a short, and we'll stop the test and check and see what's going on. If the bulb stays fairly dim and we get our voltage up to 117, 120 volts, and we don't see any smoke coming from our preamp, then probably all is well and we can proceed to test the voltages. Let's begin. I'm going to now switch on the variac. And remember, the voltage is now set to 0. When we get past 90 volts or so, you'll be able to see the reading on this monitor. Let me slowly turn it up. We're at about 20 volts now. We're now at about 50 volts. I can hear the transformer on the preamp starting to buzz, and I think the relay just switched on. We're at about 95 volts now. I don't see any indications of any problems. And there we go, right about 117 volts. Let me kick it up to 120, right about there. Okay, everything looks good. Before we connect our voltage meter, let's power down the preamp. Now let's do the voltage tests. For the first test, we'll connect our common lead to P705-3, and that's this point right here. And we will connect the positive to P702-2, and that's this point here. There's our common lead, and now our positive. And it says when we power on, we're looking for positive 26 volts. Let's give it a try. Power on. About 27.5 volts, absolutely fine. Again, there's no load attached to this power supply, so the voltages are likely to be a little bit on the high side. So 27, 28 volts is going to be absolutely fine. Let me power off the preamplifier. And for our next test, we'll leave the common lead attached to P705-3, and we'll move our positive lead to P701-2, and that's this point right here. There we go. And Heathkit says when we power on, we're looking for plus 35 volts. Here we go. And we have positive about 33 volts, actually a little bit lower than the 35. But again, this is absolutely fine, well within range. Let's power off the preamp and move on to the next test. And for this test, the common of our voltmeter will attach to P7011, which is this point here. And the positive will attach to P7053, which is back here. There's our common and our positive. And here we're looking for negative 35 volts. Let me power on the preamp, and we have almost 35 volts, very close. However, positive, not negative. Now for this test, they had to swap the P7053 test point from negative to positive. I wonder if that's a mistake. Let me go check the schematic and make sure, because everything seems to be operating correctly. However, we're getting a positive voltage where we're supposed to be getting a negative. Let me double check the schematic. Okay, here's our schematic, and you can see that P7053 is our negative point of the circuit. So in this step, having us switch the positive lead to P7053 appears to be a mistake. And here's P701-1, and with this negative and this point here positive, we should be reading negative 35 volts. So the way we have it configured, having positive 35 volts there is absolutely correct. So Heathkit, you goofed on this one. You kind of confused me there a little bit. So this is wrong. Let's move on to the next one. Power off our preamplifier. And for this step, we're going to put our common on P7014, and our positive will connect to P7013, and that's this point just to the left of point 4. There's our common and our positive. And here we're looking for negative 13 volts. Let's power on the preamp and see what we have. Power on. Okay, and you can see as I powered on the preamplifier, the voltage stayed at 18 volts. Let me turn off the preamp. And again, the voltage is staying at 18 volts. So what's happening here is because there's no load on this power supply, this capacitor here is holding its charge. And we're getting 18 volts here, regardless of whether or not the preamplifier is powered on or off, as this large capacitor is acting like a battery. Okay, now you can see we're supposed to have 13 volts, but we actually have 18. That's quite a bit higher, but again, there's no board connected to this point on the power supply. So there's no load to bring this down. So for now, I'm not going to worry about this. When we have the board connected, and I believe it's the MC board that connects to this point, we'll check the voltages then. And I imagine with the board connected, we'll be much closer to this 13 volt point. However, we still do have another problem. This is supposed to be a negative voltage, and as you can see, we have positive again. Let's go back to our schematic to verify whether or not with the voltmeter hooked up this way that this should be positive or negative, as it's quite possible that Heathkit again made a mistake with how the voltmeter should be connected in this step. Okay, here's our schematic, and you can see that there's a separate power supply here for the MC board. And point 4 is supposed to be negative 15 volts, and point 3 should be positive. So based on this, the way Heathkit had us configure our voltmeter, having a positive voltage here is actually correct. And the instructions that indicate that we should have a negative voltage is incorrect. Well, our power supply seems to be working just fine. Let's move on to the next step. In part 4, I used a galvanizing compound spray on the chassis parts, which I chose for its excellent corrosion resistance, but also for its conductive properties. The spray contains 93% zinc, and here you can see it passes my conductivity tests. Well, I've essentially completed the build of the preamplifier, but before we move on to installing the top and bottom covers, Heathkit wants us to do some hum injection tests to make sure that the preamplifier is basically working. This test will basically show us that the input section is connected to the output and that in general the circuits are working okay and that we have no shorts and it's safe to proceed. And you can see by the red power light that the preamplifier has actually passed the first test. It's powered on and connected to my current limiter and my variac, providing 120 volts. And upon initial powering on, there were no faults detected, there was no magic smoke release, so we're good to go to proceed to do our hum injection tests. To do this test, the preamplifier needs to be connected to an amplifier and speakers, and you can see that I've connected the preamp to my little bench amp and these Minimus 7 speakers. And really all we're going to do is go through the different inputs and inject some hum into the system and make sure that we can hear the corresponding buzz from the left and right speakers. So the first input test we're going to do is auxiliary 2. Let's make sure that it's selected correctly. So tuner, auxiliary 1, auxiliary 2, there we go. Okay, now what we're going to do is essentially input some hum into this auxiliary 2 input right here, left and right, and make sure that we hear the hum. So let's start with the auxiliary 2 left. I'm going to put my screwdriver there. Let me turn up the volume a little bit. Great, and I'm getting hum from the left speaker. Great, let's move on to the right. And now hum from the right speaker, so this input is working correctly. Let's move on to auxiliary 2, over here. And that input is this one here. This is the left, auxiliary 1 left, and the auxiliary 1 right. That's working great. Let's move on to the tuner input. And that's this input here, our left, and our right. Great. Next we're going to move on to phono 1. Now for this test, Heathkit has indicated that the overload LED should light when we do the hum injection test, so look for this LED to light up. Okay, let's try the phono 1 input, left. And the LED light is indeed lighting. Let's go to the right. Perfect. Let's move on now to phono 2. And again, for this test, the LED overload should illuminate. Phono 2 left is here. Great. And right. Perfect. Now we're going to test the phono MC. For this one, the LED overload should not light. Let's select phono MC. The phono MC input is here. This is the left. Let's start there. Perfect. Now the right. Perfect. Our preamp has passed all the hum injection tests. Let's move on to installing the top and bottom covers. Actually, before we install the covers, I thought I'd give you a good view of the topless and bottomless preamp, all built and ready to go. This view is from the top. And this view is from the bottom. It's a well-designed and, if I may say so, well-built preamp that's ready to provide years of service. Okay, let's cover this beauty up. That completes the build of our Heathkit AP1800 preamp, but we're still not quite finished. Stay tuned for the next episode where we'll test all the preamp's functions, test its frequency response, harmonic distortion, signal-to-noise ratios, and more. And I'll demonstrate it working in an audio system. To stay updated, please subscribe to my channel and click the bell to receive notifications when I release new videos. And if you like this video, please give it a thumbs up. I'll see you soon.